Okay, so we are going to cover Unit 9. This is actually one of the shorter chapter in the textbook. And my plan is for next week, you just have a quiz because we're not going to have class due to Halloween. Um, so the quiz is going to cover from Unit 1 through 8. And then we will take care of the second part later. When we come back from Halloween, I'll release the project and we'll go over the project information on what you need to do as far as the project and build out some of the components um, for the proposal. Okay. So the beginning of the chapter, it's very business oriented. It talks about how organization have standards and requirements. So this chapter focused on industry specific operational requirement and how that relates to the security aspect and the technical implementation or deployment that we have to support. So the first part talks about health and safety. I think this is standard across many industry, including for education or even other type of industry that's not listed on the page. But as you go through, you would see that the regulations is required. So compliance requirement can be there will be specific details on how the technical setup would be. Additionally, you would have certifications for the national or international standards, and we'll touch on that. And what kind of requirements we have to meet in order to obtain that certificate, so that way our customer can have the quality products or service that they need. So in the first question, it asks you to describe the International Organization and Standardization ISO 9001 and 14001 for manufacturing. This is a big area for manufacturing, I think. And then we, in support of products and quality of products, you would see that manufacturing. Hi, Amy. You would see that there are some baseline requirement in the practices for manufacturing. So the ISO 9001 standard, and this was not fully included in the textbook. This is something that I added to the notes so that way, in the case if you provide security support for the manufacturing industry, you would know there are a lot of them around here. So we would know the type of standard we need. So the ISO 9001, which is part of question one, it adopts the principle to improve performance. Basically, the companies that are certified in this area strive to provide quality products based on the customer experience. So this is why you see a lot of survey feedback. How do you like our products? Would you refer our product to someone else? You would see those type of analysis or assessment. So with the requirement, it really comes down to the operation of the company. That means that they have to have quality leadership. And also the employees' engagement in the company is also important. So engaging the employees in and include them in the contribution of the company's overall goal. And then they have to continue to improve processes, and this has to be provided in the documentation when you apply for certifications in ISO 9001. And then you have to also provide evidence-based decision making. What does that mean? We would have to make the decision based on data, on how certain type of data would impact, systems, people, operations, and so on. So your decisions is going to come from evidence, and we would look at the cause and effect of that type of decision. So if I make a certain choice for the operation, so for example, on the technical side, we can make a choice like upgrading our systems so that way our manufacturing plant will be able to have more efficiency. You have to provide evidence that there's cost analysis, there's risk analysis that would be involved. So you would see the cost and effect of those areas. So ISO 9001, to really sum it up, is it's about um, really integrating what the customer needs are and how that's going to go into the processes in building better product. For the ISO 14001, this is mostly for companies that would, in manufacturing, that might have environmental impact. So it really look at how there would be waste or consumption of resources that would impact the environment. And the application of this would entail how we would improve processes and then execute the plan. So and you probably hear a lot about green IT on how we should be efficient with energy usage. And that can be a small factor in this particular area, right? But overall, you would see that company, when they produce product, there's a lot of carbon footprint in various products, especially with plastic-based product, or even paper products sometimes can also cause a lot of carbon footprint. So ISO 14001 really look at the impact in the environment and how that can weigh into your overall production, and then implementing the processes to be able to execute what is planned, and then analyze how your product's outcome would be. Is it better? Is it not as well as what we've seen in last year? Because in some cases, you would have to weigh in the changes, right? We have to implement change management and also how successful that would be as far as the result. So there would be some effort in research and prototyping before all of the processes can be implemented for production. And why is this important in IT or cybersecurity? It's because sometimes changing processes means changing software. It also means changing storage. And then the practices behind for the operation, it also, we need to think about how our system can be integrated for the the greater goal of the company, right? So all of these elements are important. When you look online about manufacturing and ISOs, there are a lot longer lists. These are the two more of like the specific or the more general one. I omitted some of the specific ones. So if you work for a company that is producing steel or having a steel plant that processes steel to make tools or other things, there are specific ISO that they need to follow. For example, like the materials certification. So they have to utilize quality materials and certain type of material. And then when they cut the steel sheets or rods, it has to be a certain width or length or thickness. So, and then if you look at manufacturing company that use glass product, they have to go through other ISO certifications. And how that can impact the technical side of the house is that when you change the requirement in operation, you really have to change some of the technical aspect, right, in operation, like the systems that we use, the software that we use, and then be able to adapt the people, the user for those type of systems. And then sometimes that can also change the how our network systems would be, our infrastructure, the applications that would entail, making a better product, right? Manufacturing a better product. So overall, you kind of have to understand a little bit about the requirements. And then in this case, if you're obtaining customer feedback, right, a lot of that is going to come back to data retention, and then, using applications to be able to issue some form of assessment, like a survey for the customer. And this is what you see, like when you go to a restaurant or any kind of things that you buy, right? On the receipt, it would say, we want to hear from you. Can you please give us some form of feedback? So I think in many industry, you would see that there are focus in how the customer experience would be and the products and the services that's being provided. But in manufacturing in general, this is an area that we would see for standardization. And then for the environmental impact, I think overall, when we're looking at all industry, right, we want to also think about how the things that we use, the resources that we use, especially in the IT area, the data warehouses, the data center that you currently own, or utilize, right? How that impacts the environment. But manufacturing company, they have to look at how their waste, can be, a factor in environmental risk. Okay. And this is where you see a lot of companies are being fined or, have to go through various litigations because, for example, dumping in natural, like dumping resource waste into the natural resources, like waterways and other things. So I think that we have this in place to make sure that there are proper control in how products are created and making sure that it is safe and healthy, right? That's the whole point at the beginning of the chapter. And so with that, we look into healthcare. And I think for the chapter, it really kind of very briefly highlight what HIPAA really entails. I included some of the verbiage that you can find from the actual website. When you look into Health Insurance Portability Accountability Act, this was established and been modified over time. I think the most recent modification was 2020. And so this allows or requires health provider or organizations that hold health records, making sure that they protect, right, your personal health records. And this is critical because health records is really unique to the individual. And with that, we would require data privacy. So this is a big area for many organizations, even when you're looking at non-health service provider, like hospital, right? But if you're looking at like an institution like education institution, they do have health services, so therefore they also have health information. Or companies that, have health records of the, like tech companies sometimes that they would provide services like mental health support. So they do have that type of data or even insurance information, right? So that is critical in how we protect it. And the baseline of this, so there's an emphasis for me in this area quite a bit, right? In how we would protect the data with encryption, we want to make sure that all the communication systems is transmitting data in a secure way. So it tells you here that there is a strict control for protected health information. So whenever that there's data leak, usually, after the reporting process, there usually some kind of fine if you're not protecting your data appropriately. Okay. So we need to make sure that things are stored properly, like data that is being stored. And then for the data that's being transmitted or in transit, that needs to be encrypted and it needs to be transmitted in a secure channel. So the security rules required the entity to make sure that there are administration, right, in technical and physical safeguard of health information. So if they have paper files, right, like when you go to the doctor, usually if the office doesn't have a tablet for you to use to fill out the information, you're required to fill out a form. And that form is then being scanned into the system So your health information has to become electronic. However, how they maintain that form that you completed is very important, and that's also physical safeguard, right? They cannot just throw it in the trash and then it becomes an element for dumpster diving. So overall, we want to make sure that we have the technical, the administrative, and the physical safeguards. And what does it really do? It's gonna hit the cybersecurity area. We're gonna make sure that the data has integrity and it is confidential for access. So it will be to the individual, right? And then when that data is being transferred to other entity, the individual must authorize the data to be transferred. And then the data needs to be available for the people who access it, like physicians, nurses, right? Service providers, and then even insurance company or the patient themselves when they're requesting records or accessing records online, right? It has to be secured. So how it's maintained and transmit. And with this, we have to take a look at the infrastructure. Like the network that we're using, the systems that we're using, software and hardware, does it have the capability to meet the compliance, right? For HIPAA. And then we want to also have anticipation of threats. So that means that you have to do vulnerability assessment by the baseline in the requirement. So you have to have potential threat information analyzed. And then you also need to make sure that your information and your data has integrity. And so with that, we would look into technology like hash algorithms, and making sure that we encrypt the data, and then the access level to the data, so permission control, right? And then so there are various layered approach that we want, and how we are looking at threats, internal threats and external threats. That's important. Okay. And then for the security rule, it requires that you protect your data against impermissible use or disclosure, right? Like data leak, breach, or even accidental disclosure of information, right? People might accidentally send a list to someone else that is not supposed to have the purview of that information, and so on. So we want to make sure that we have precaution measure, and it should be a proactive approach. In security, we look at this and we would say, so there's a lot that would go into this area, right? Outside of permission control and access control, you also want to have things in email systems or your email servers, also checking for malware that could be damaging your data or circulate your data elsewhere. And then be able to make sure you train your users. So there are a lot of elements for security in this area. And then making sure that we fulfill compliance. Okay. There is a website that you can also visit to, I think I did that with CIS27, right? And other classes to kind of show you how frequent or how many organizations actually have healthcare information leaked. And it's very common that you would see that, right? Whether it's accidental attacks. So those anticipated threats need to be assessed, and you have to look at the risk behind that. Hi, how you doing? Any question? Okay. So for the next section, it talks about public utility regulatory requirements. And for our notes, we're just gonna focus on some international standard, but not and regulation, and then for the majority, it will just be United States based. So the public utility, their requirements would be the PURPA, Public Utility Regulatory Policies Act. And this is mostly to control how pricing and the reliability for power generation, or resource generation and how it's delivered. So it aims to look at the domestic energy and renewable energy. So when you're looking at that electricity in general, right? How the service provider like Edison or other companies is able to offer energy to the household or the business. And then also having programs for the business or the household to generate their own energy to connect back to the grid, um, as a shared resources, or also, right, the compensation and the price that we have with this organization. So the enforcement of this particular rule or the requirement, um, is really coming down to how much they charge, right? Of late, you might hear that a lot of people are saying, public utility company such as Edison have been raising their price because there's a higher demand for energy. In an enterprise environment, you would see that energy is one of the higher cost item, that the companies might have to pay. So, and because all things electronics utilize some form of energy, whether it is battery based, right? Or through your electrical systems. So the utility company, they have a requirement on the charges that, like there's a range of charges that they can follow. So it must be fair and it cannot be discriminatory. Okay. So that means what? They cannot charge one customer a rate and another customer of the same tier, right? A different price. It has to be fair and it has to be non-discriminatory. And then there has to be control in how the prices rise. And I don't think they ever fall. They just continue to rise because there's higher demand for energy. And how it would, if in the case that it reached the maximum, the cap, right? So in the case if we have inflation, the economical ground change, and so with that we would see that there's price changing. So some of it, there is a ceiling, you can say, on how price can, or the rate can reach, and not exceed a certain amount, right? So they have a cap on that. Otherwise, you're going to have a lot higher rates. And you don't see that across all the countries. So we're fortunate that we do have this regulation in place. So that way even though electricity bill is high, right, it's not extremely high like what you see in some other areas. And, and they talk about how sometimes it is, some cases it's state-based, but federally, you would see that they have to have a requirement for the federal based on the regulation that's stated. Okay. But then there are cases that, like for example, in Hawaii, if you're looking at a lot of the utility company, like gas and power in Hawaii, the cost for that is a lot higher than what you see in the mainland states. Like if you compare that to Florida or some of the coastal state like us, California, right? Hawaii rates are tremendously higher. The argument behind that is the cost in Hawaii overall, right? And the cost in support and maintenance for the systems on the islands can be different than what you see on the mainland. But I think, with the state support and some of that comes back to the political issues, and who's in leadership and so on. So what you see is, yeah, there's something that's federally regulated, and then there's exception because there's state law that allows certain things, right? And I think that was mentioned briefly in the text as well, but you would see that across with a lot of different type of regulation. So here it talks about energy sector. And then you have the Environment Protection Agency, your EPA, who really is, you know, in by definition, they're supposed to have enforcement to protect the consumer, based on the compliance requirement. And then you also have like non-monopoly requirement where you do see that there's certain service provider in a certain region, right? But then they cannot be across the entire state or the whole nation, right? So you do see that they can be some of the primary because they are dominating in some area, but they cannot be across all areas, right? So they have a lot of that for communication and utility-based companies too. And then I think I touched on the quality control for that's using ISO for manufacturing. So you can refer to the notes if you want to read a little bit further or, more in details. So for four, we're gonna move forward and we're gonna talk about some of the technology, right? I think the beginning part of the notes, it really goes into like specific industry. But if we're looking at industrial systems or in manufacturing or even at the utility company, we often see that there are embedded systems, right? Um, in computer science and engineering, they have to dive a little deeper on how to engineer these systems and how to develop applications or write instructions for the embedded systems. And to really understand a little bit better about the embedded system, an embedded system is simply a computer system that has instructions or software that's designed for certain processes. Okay. And embedded system can be used for farming, it can be used for manufacturing, it can be used, even some of your household systems can be embedded systems. Now, unlike the microcontroller embedded system, usually, overall, when we're looking at the technical aspect, you would see embedded system would have like operating system or a more full-fledged software where microcontrollers are specifically executing a certain set of instructions only. So when I'm looking at embedded system, it could be, the red box that you use to rent your DVDs or whatever, and those are diminishing because I think we're doing away with the optical disc. Or the Coinstar that you use to deposit your coins. Embedded system can, because it's really designed for that specific purpose, right? Coinstar system is only for you to deposit coin or exchange your coins for, bills, money in paper form, okay? Or digital money, ultimately. So if you think about that, embedded systems is really designed for certain processes or certain purpose. So when we manage these embedded systems, it's best that we put them on a network segment and we should manage that network segment separately. Because depending on the use of embedded systems, so they can be for full automations, or they can interface human beings. So something like the kiosk that you use at the airport or train station or bus stations, all the way to what you see in the supermarket like Coinstar or the rental kiosk that you see, right? And that is mostly for self-services purposes, but you have fully automated system that's used in manufacturing and supply chains and a lot of things. So what we have to do is on the network environment, we got to make sure that these systems are segmented. That means that they're connected in their segment, and we need to manage their segment to support their purpose and their goals. So, any questions? So in security, when you're using things like switch routers, security appliance like firewall, they are a form of embedded system, right? The firewall, its job is to filter. That's it, right? It runs embedded Linux or command line in the back. If you're looking at Cisco, it is really built around embedded OS. So some of the commands that you see is the same thing as in Linux command, like IP address. So embedded system, normally you would see them is Linux in the back. Whenever that you go through drive-through and you speak into the kiosk and and they punching in your order, the ordering system is an embedded system. If you see like if they have malfunctioning system, you see it boots Linux in the back, right? So the interface that you see is just an overlay application, so that way the person who takes your order, they can tap the button on screen or the button on the keyboard to input your order. Cashier system is like that too. Many of these things that is around us all the time is really embedded system, and we're just not aware that that's by definition what it is. So let me go to view. Okay. There's some information about facility services, and we'll come back to this when we talk about SCADA or um, your system to manage buildings and things, or the resources in the building. But if you look at page 6 and onward, you would find more information about embedded systems. And they've been around for a long time. I don't, a lot of the things we use is just an improvement of what was in the past. So over 50 years, I think that our embedded system has changed in how it's used, and the purpose for these systems have also changed based on the need, right, of the users, of the consumer. And with this, we will come back, right? We talk a little bit about how we would manage that in IT, and we'll come back and touch on. So the security behind this, because they are embedded system, you got to manage them as a system, as a host on your network, and ultimately part of your infrastructure. So what you see is that you gotta, because they are specific to certain objective, right? You have to think about their functionality and how that plays into the operation of the company. And we got to make sure that we protect the security so the processes is not intervened. Then we have Internet of Things, and this is a lot more popular now than it was in the past. Internet of Things can be many things, from your Alexa all the way to your smart devices like your smart TV. So now question 5 asks you to provide an example, and that, you can add more to it. Internet of Things can be your wearable devices like your smartwatch. But if we're looking at like household appliances and or electronics, we see that a lot of them are Internet of Things. Internet of Things could be your security camera that's connected to your wireless network or your wired network. But it can also be your smart TV, your smart thermostat, your speaker that you can provide voice command to, right? Your smart speaker, your smart refrigerator, and many things that we use. So as long as they are a system that can be connected to the internet to share or to have their data be available for access for various reasons, then they are Internet of Things. So to support this, from the security side, the number one area that we see is firmware patching. The downside of this is it really depends on how the manufacturer produce these systems, right? Some systems are more maintained or updated than others. And so we can't assume that out of the box they are fully secure, right? Many of them will promise encryption and secure communication. You have to take a look at the technology that's built within the protocols and the services that's used. So the number one area that these systems fall down a lot is going to be your wireless. How wireless access is security measures are, whether that's in place or not. Even if if you use a certain technology or encryption for the wireless, we have to really ask, is this encryption going to withstand the type of threats that I'm going to be facing? So outside of home, if you take this aspect into a business environment like a hospital, right, or a manufacturing company, or like something like logistic, or like FedEx, UPS, you see that Internet of Things is being used all the time. The hand scanner that they use to deliver your packages that was shipped. So outside of patching, we want to see how we can protect the connection and the interconnection of the system in our infrastructure in the enterprise. And system hardening is a lot more than just updates, right? You got to make sure that you protecting it from malicious software or malware. You also need to make sure that authentication and everything is also in place. So system hardening is like a broad spectrum of things that we would implement for the basis of the protection of the IoT device. And I think that there's just one chapter that's dedicated to that, right? We talked a little bit about mobile devices last week, and some of those, things would be carried into the IoT's area. So for the next area, we would see some information on system on chip, and this is SoC. And this is basically a CPU, memory, storage, and IO. So it is a computing system, right? In a small format, or maybe a compact way. So it has to have some way to be able to interface. So when you have input output, it need either interface with the human or interface with other systems. Okay. There gotta be some form of internal storage and also temporary storage. And then it needs to have a CPU. So if you're looking at some example for these, SoC can be your tablet, it could be your smartphone, it could be your Fire Stick, right? Because there is an interface, some form of input and output for that. You've got signal input with the cable. And in some cases, there might be other devices that you would see that would fall under that category. So when you're looking at SoC, the processor that would fall under this area, that would include your Apple M1 or M2, right? And then you got the ARM processor. So ARM processor is in a lot of your Android-based devices. From the tablet that you use that is Android, all the way to some of like the smart speakers and things that you have. So these are the some of the example for your processor. Like if you think about like the Roku stick or the Fire Stick, like the Fire TV stick, right? That you attach to HDMI connection and things like that. It has a processor, it has storage, it needs power. When you connect it, you have a software interface. So it is a full computing system. It's just in a different form factor. Yeah, many of those would use some kind of SOC like this, right? I used to be fascinated with various more compact based type of system that use SOC. So whenever they would come out with things like Intel stick, I would get it. And it runs full embedded Linux, so you can boot it. Very similar to what you see with Live Linux USB, where you just plug it into your TV and you have a computer, and then you can connect your wireless mouse and keyboard, and then you can use it. Very similar to what you see with Raspberry Pi and other things. Right? Okay. Then the next question is gonna lead us here in the application specific integrated circuits. So when you're looking at the computer system, motherboard is a board of integrated circuits, right? ICs is everywhere in electronics. Whenever that you see, even in toys, whenever that you see like a board that's attached and it would have some form of instructions, that incorporates integrated circuits. But ASICs, they cannot be reprogrammed. So when they are built, they're really built with a specific program for a specific purpose. Okay. So for example, I go and I buy a toy for a kid. Let's say a little puppy that barks, right? That particular toy integrates ASIC. Okay. And I cannot take that chip that's integrated inside the toy and program it or modify the instructions for it. It is written to an area of the storage where it's not programmable. Okay. The old cell phones that you see, right? Those are not programmable. They are really used for a certain purpose, right? If you're looking at your digital watch, like the old school watch, like not the new Apple Watch, right? The digital watch that would have just the number that you see, not even in color. So in that case, when you're looking at these systems, you would see that the ASICs, they're really made for a certain purpose. But they can be vulnerable because if they're built with flaws, it's hard to really fix that problem, right? So the reliability behind it, it's really depending on the manufacturing company, on how that's used. But there is a wide range of ASIC that we use for different industries. So if you're looking at aerospace, if you're looking at transportation, there are a lot of different ASICs that we use, and it's made for a specific purpose. So for number 6, it asks you to provide some examples for ASIC, application-specific integrated circuits. So the application is really made, right, for a certain objective for that chip set. And how can a vulnerability be remediated with ASIC? So the example would be your electronic toys, right? The next time you go to a general store like Walmart, Target, right? You look at the electronic toys, and you would think about ASIC like a toy car, right? The RC cars, the helicopters for the little kids, or even like, talking stuffed animals and things like that. And then in some cases, you would see like Bitcoin mining systems. So we mentioned that the vulnerability cannot be remediated for the existing ASIC. So once that's built, right, that's not modifiable. That's not reprogrammable. So so let's say that if my company use a system like this, what can I do to fix the vulnerability, the security vulnerability? Replace that system. We have to retire the old system and replace it with the new system. So to really fully mitigate it, you have to have a replacement. So that means that a new application has to be created for a new ASIC system. Okay. There's no way that we can go back and patch it. There's no such thing as patching for this. Okay. So it is just a one way. So this is why you do see some versions that come out, right? Like if you're looking at things like, we can just relate like electronic toys for kids. You would see that, maybe last year the version have some bugs. Um, maybe it's not functioning as it should, or it doesn't last. Normally they would reproduce the toy with a version 2, and they have to adapt a new ASICs, right? So the next line of production is going to be the next generation system with a newer application. Any question regarding ASICs? Okay, so I'll have you go through this link. You can control click it, and it takes you to an article by Spiceworks. And it talks about FPGA. You can see some information in the notes, but it's very brief. This is field programmable gate array. And it gives you the breakdown on what it is, how it works, so that way you can have a better understanding of what it is. Okay. So FPGA is a form of integrated circuit. It is an IC, right? And it is made of semiconductor material. And semiconductor goes into a lot of things. Your CPU, right? If you buy a video adapter, there's semiconductor that's integrated in that. So integrated circuits, but this is field programmable gates array. So the difference between your FPGA and ASIC is that ASIC cannot be reprogrammed, whereas FPGA is programmable. So when let's say that your company uses FPGA, right? After that it is purchased or acquired, you can program it, right? Okay, so as you go further, it talks about how like the common format for it. So how can you reprogram it? Well, you would have some form of input and output interface. So in this case, I talk about pads, and it uses the programmable logic block. So the flip-flops memory blocks is utilized for the memory components. So it uses things like logic blocks. And so they do have microprocessors for your FPGA. And so to answer this question, you would go down the article. So at the beginning, you can define what that is, right? We already answered this question in comparison with, this should be, sorry, there's a typo, ASIC. How is FPGA different? FPGA is reprogrammable, where ASIC is not. So what kind of language do I use to program AFPGA, right? So as you go down, I think I can show you the section. Yeah, so here you should see it talks about Verilog and VHDL. So very different than what you see in like your regular. So when we talk about high level programming, a lot of the times we would go with like C-based language and so on. And FPGA, it's been around for a long time, so it uses these two languages. And it talks about how a common language for AFPGA is your VHDL. So Verilog and VHDL, the programming languages, and um, it is a way that we can program the integrated circuits to execute certain requirements, right? To do certain things. So here it talks about how you can configure the logic block. I think it talks about how it carries that and treat it as cells. So it works at with the control logic where and we will get into the programmable control logic, which is the next section. Okay. But it also uses multiplexers. So you do have information. So at the low level, you have the flip-flops, the gates. So where do we see gates? We see gates in computer systems, right? This is when you can have applications in when you're writing a loop in programming language like if else, right? If this happened and this, right, it's gonna have produce a certain logic. So logic gates are really designed for that, is to give you logic, and so that way you can write the application that you need. So it still have the logic, but it's structured a little bit different than some of the other integrated circuit system. You can have it interconnected or connected, and there is programmable routing. So for the next few questions, it says, how can FPGA interconnect? You need to refer to this section of the page, right? So it talks about using semiconductor switches for interconnection for AFPGA. So it uses a form of switches for interconnection. And these switches are programmable switches. And then you can also set routing path. So it is able to, FPGA can interconnect with one another, right? And then can communicate throughout. So there are programmable routing. Hello. So we see these sections for D and E. And it asks you, why is programmable routing used for FPGA? So here it mentions that, what was it? In the design, it's hierarchical. That means that it carries top tier down, right? You can connect the gate arrays to communicate from top level down. So you have hierarchy. But ultimately, the goal behind programmable routing is for density and performance. That means that if you have many AFPGAs, right, we're able to reconfigure or change by programming the routing process, so that way it would be able to handle more loads or you know, the density for communication. So look at this paragraph for the last question. Okay. Then we get into PLCs and how PLCs is used with SCADA. Let me get to that section. So one of the things we want to also note is uh FPGA does have CVEs depending on specific type. So you do have vulnerability. And so we want to make sure that we looked at the vulnerability and how that vulnerability can be remediated. And it says around 70% of the attack against embedded system and integrated circuits are performed remotely that do not require authentication and exploit to be exploited successfully. So that means that because these systems are a little bit more simplified, you don't have a way to log into it accordingly, or you don't have a secure authentication process. So once that they can connect to that system, they can likely exploit that system. So how you allow connection is also important. So that means that we have to look back, and we wanted to make sure we update the firmware to protect, right? To remove any kind of bugs or vulnerability. Also, we want to look at how these systems are interconnected. Okay, how it's used in our infrastructure. And there's example, and it talks about Starbleed. So physically, you would see something like this. Okay. So ICS or ICs are integrated circuit systems, and it's used in industrial systems and also for manufacturing and process control. Now, when you're looking at SCADA can be used for a lot of things like controlling lights. So for example, like for a campus like this, we want to set up where lights can turn on, or even parking lot lights can turn on at 6 or 7 p.m. when it gets dark. Or controlling thermostat across the building's temperature. So there are many things, controlling utility use, or even production for manufacturing. So you would have system that supervisory computer. These are the controller, right? That manages all the other components. So when you walk into like retail stores and things like that, right? They have a system that control the refrigeration. I think that they're doing away with like the individual units, right? All the units are interconnected. So that way we can monitor like the temperature. Like let's say that I have frozen sections and I have refrigeration for milk and dairy and other products. Um, so you might have something like that, or even in the warehouses, you might have like refrigeration warehouses that require supervisory system. So you see a lot of that in logistic area, in manufacturing and supplier and so on. So this is a good example of that. So you have the HMI, which is a way that we as human can interface with the computer that controls the other elements of our facility or our process, right? So in my plant, I might have equipment. So let's say that for my company does oil drill, right? You would have sensors, you would have equipment, you would have motors, you would have generators, you would have tools, or even producing steel. So in manufacturing equipment, you might have sensors and things, and those sensors are controlled by programmable logic. Okay. So I on the plane one time, I was flying somewhere and I had talked to a technician that serviced refrigeration systems, right? And he goes to supermarkets to do that. When we started talking, because I used to service the cash register or the IT part of the supermarket. So whenever that you walk up to the cash register when you're using transaction system, I used to service those long ago. And then he tells me that he serviced, you know, the refrigeration where you go and you get your ice cream and so on. And I asked him, I said, you know, what kind of skills does it take to do that? And he said, well, sometimes you got to connect it to the network. They are programmable logic systems. So, you know, you just run the instructions and it's C based. So I said, okay, I understand. So you would see that equipments and things that are controlled by PLCs are generated with instructions using C-based language or that form of instruction. Sometimes they use shell-based stuff too. But things like, you know, uh check monitor alert when temperature would go down. So when you have system that goes down, right, it would send alert notification to the supervisory system. It's saying that that refrigeration unit is down, right, or it's not up to temperature, or there's leaks and so on. So that way there's a way that they can dispatch the technician to come out. Normally that gets contract out to the vendor who provides the refrigeration service. I actually know some of the engineers that worked at the plant near Ontario that produce. So when you go to Starbucks, all these beautiful glass case that you get your cakes and all your pastries from, right? It comes from a national company, but they have a close by manufacturing locations. So you would see more modern, and there are a few of them in the nation that does that, right? But surprisingly now that you see that all of these are connected. So PLCs, right? How they're used with SCADA systems. PLC receives the information like from sensors, and we can use like temperature as sensor, temperature for cold and hot. We can also look at that as moisture. So in the case if you're looking at things for farming, it can also detect like soil moisture and other things. So they would plant that. I was on a project with another company long ago. They were implementing smart city in some part of the world, right? So when you're looking at smart city, they would have a lot of the sensors, things like for train tracks. So in the case where if there's human that's trying to lay themselves down on the train track, right, they would have some form of notifications to monitor that, or wildlife that cross. Because when you tear down some part of forest to build out the train tracks, the engineers, they have to go in, they have to take a look at how that can be safely implemented into the environment. Um, so, and then, you know, from kiosk and things and communication that's integrated, sometimes you would see that they would have control like that for transportations and so on. So PLC program logic controllers, they're really used for sensing for actuators, like for movement or even some robotics area, and then also for pumps, right? Like for water systems and things like that. And that allows some other automations. Now the HMIs are really just a way for the human to interface with the actual system, right? It is a way that we can communicate or utilize the software to be able to modify what we want from the system. Yeah, so if you don't, yeah, mine didn't have that either. Um, I think on some of them, they waited a little while longer to have that populate that one. So if you don't have that, you just look for the, so you know what's going on. So just do the first percent. But yeah, you might not be specific. So for the bottom, what happens to the bottom? Look at the fourth email or the third or the fourth email. If he would say something earlier about something. Yeah, that's what happens. Okay. And then the historian systems. So I have AA database. Is a database. Logging systems. So whenever that you have controllers, right, it generates logs. So when you have sensor instrumentations or other controls, the logs is going to go into the database, and that database is called historian. The way that I remember this is because there's historian as data historian. So it gathers all the data and history of the system. So if you have like sensors with PLCs, then you would it all that data is gonna be the repository of that data is going to be in the historian system. Now, this data is then interpreted and analyzed so that way you can change your processes. So we can say, because of the instrumentation, so if we're looking at like utility company or a company that provides like resources like gas and oil, when they drill for that, right? They will make adjustment based on the sensor. So the data is being analyzed, and then it goes back to the engineers, and the engineers, they would modify the process for that particular, to improve basically. So that's the whole point. And why is it important for us? Well, this data is important because it really tells us how the performance of the sensor and the instrumentation system. And if it falls into the wrong hand, right, that can be, that can cause some damage. So when you're dealing with the grid, right, gas systems, stuff like that. So HMIs is here, right? Supervisory system, and it talks about how PLCs is integrated is there. And when they're referring to OT, it just means on the carpet. So that just means that like the industrial type of organizations or systems there. Okay, so one of the things that you need to know is PLC do not use your operating system like Windows or Linux or Mac OS, right? They have their own specialized OSs and the instruction to go with that. Okay. So an example of that is this. So you got the Siemens POC models, and then it talks about historian here. So ladder logic. Ladder logic is a programming language. This is used for relay-based logic. Think of it like the ladder. You have to go from the first step to the second step. So it's a form of relay, right, in the logic. And the way that it's designed is rung like a ladder, and then it's going to go top to the bottom and then left to right. Why is that? Because as human, we design things that really represents us, right? We see things. When you look at things, you normally look at top to the bottom, and you read in Latin-based language is going to be from left to right, right? In other part of the world, we read right to left. So it's really the ladder logic process is designed, right, where it's going to execute from top to bottom and then left to right. So you would have like sensor inputs. For example, like this sensor input is for quantity, and then it's going to report to the next is going to be clear, and then it's going to, so if you think about like manufacturing, even for conveyor belt, when you're looking at conveyor belt where it's gonna open up, let's say it dropped the box, and then somebody on the conveyor belt put things into the box, and then that box get grabbed, right, by the actuator, and then that gets moved into something else, like could be a robotic arm, and so on. So all of that is really sensors reporting out to other sensors. And then ultimately, so it's gonna be sequential until it gets to the output 3, right? Where that actuator opened the gate. So when you're thinking about shipping and receiving areas of the warehouses, it actually used something very similar to this. So ladder logic sometimes is um, fully integrated for automation purposes. So basically, the logic cannot occur in the middle, right? You have to go from the start, which is the left, to the next step, to the next step. So some sensor has to be activated. Now, the things that fall down, right, when you have things that are backed up, if you're looking at conveyor belt, uh, is when, right, things don't happen in the first stage that activates the second stage, because now then you get a bunch of things just get backed up from the first part. So to troubleshoot that, they would go back and they would go to the first step and see why that sensor is not activating or not reporting out, um and so on. Okay, sorry, I have a little bit longer for the historian, but you can grab that information from bye. From the that section. But I forgot to mention that historian system is the 3 components, and you can find this in the notes. It collects the data. So there's data collector, and that data came from the programmable logic controller, your PLCs, and devices, right? So if the PLCs is connected to, your network at large, then that data is then being sent to the historian system. So it has a way to collect the data. So that means that it has to queue those systems, right? Query them and their status and whether they have things to report or not. Then you have server application or software that stores the data after it's collected. Because it's a database, it's going to put in, like, for example, system A reports at 5:04 p.m. this, right? System B report at 5:05 p.m. this. So it would put that into the database. And then from a client standpoint, there would be another software that would be used to look at the trend of the data, right? So when I look at that, I would say, okay, well, my machine is in this section is performing well because there might be specific instruction for those machines compared to other machines. And then for ladder logic, so it is a programmable language. You can pull this from the notes upon relay-based logic. It's used for electromechanical relays. So you are going to have multiple inputs or signals to perform a certain function. And to design the circuit board, the engineers would use ladder logic to activate the mechanical relays. So we would say top to bottom and then left to right. And following that, we would have information on safety instrumented system, your SIS, SIS, and how it's used, where it's used. This is a fail-safe system in the case if there's life-threatening or there's condition for critical environments. Gas station has this. right? Or when you're looking at nuclear plants, they would have this. This is where they can turn things off, right? You've probably seen movies with spaceship or a certain area where they can just pull the lever and everything shuts down, right? That's a fail-safe system. So that's a CIS, okay? So the purpose of this is it does a reset. And on the spaceship, you normally see that it has a countdown. You got 60 seconds to get out of a certain area or everything gets closed and turn off, right? And that's a fail-safe mechanism that they implemented. And in the case if there's things are threatening, right? Like things that explode or it would combust, and so on. So that means that there would be sensors that's implemented. Could be temperature sensor, pressure, right? Thinking about if you're looking at like submarines or even outside of, now we're going to go from the sky to the ocean, right? Yeah, there would be sensors. So we would look at like water pressure, air pressure, things like that. And these programmable logic controller, how that's managed. So when you're looking at things that we send out to space, like the Mars crawlers and things like that, but whenever that we house human being on it, like a spaceship, right? We want to make sure that we protect the live form that's inside it. So normally you would see implementation of fail-safe. But naturally here on Earth, what you see is power station has that, refineries for petroleum or gas production for mining and other industrial environment. Okay. Next is gonna be your heat and air conditioning system, heat, ventilation, and air conditioning, right? HVAC. Why is HVAC important? We had breaches through HVAC before. Target was the big case that we've seen in the past. HVAC is controlled with automation, right? At home, we can have it automated through our smart thermostat, right? If you're using Google Nest, that's a form of centralized system that can be controlling others, which is going to be next. But HVAC in a facility like a college campus or in a big enterprise, you would see that you would control that through SCADA, through a supervisory system. And so for the building automation system, this is known as BAS, or you can also set up a digital control through the dedicated network. They are all networked and we monitor them. The reason why is in some environment, you have to have a certain temperature, like your data center. Your server will overheat when it's too hot, right? In semiconductor plant where my parents used to work, it is a dust-free, proper environment. You cannot have things that be floating around and it has to be cooled a certain way. Temperature has to be controlled and there's proper airflow, right? So in some environment, in order to have production, you have to have proper HVAC. So, and you've seen that with like a lot of the manufacturing too, like you have to have ventilation for the dust to fly into a certain area. Otherwise, you're going to have contamination, right? So, even in a chemical related environment. So the products that we use, from beauty products to things for household products, right? Some of that we would rely on HVAC. It is a lot more important than what most people think of it. We're like, oh, okay, it's just gonna cool down the building. Well, it's more than that. You keep the moisture away, the heat away or at bay, right? And in some cases, you have to neutralize the environment with the proper temperature because bacteria can grow, right? Food production, there's a lot of things that can be involved. or even in the warehouses when we're dealing with refrigeration and such, right? So that's important. So remember, put it on a dedicated network and monitor that segment of the network. We cannot, right, based on target case, put it on a regular network because that's how they can get in. Normally, these systems they lack a lot of the security control. So you want to make sure that you control it through a segment, a group, an area of the network. Okay. And then some of these things, you're like, why are we reading about this? Well, they have vulnerability issues. Okay, so let's talk about CAN, or Controller Area Network Bus. This is used in car industry, automobile production. I'm sure you've seen or heard about car being attacked, right? Someone remotely controlling the car. This is why. Okay, so we need to know about this. A lot of people will say, oh, it's because of the IoTs. It's actually because of the controller bus. Okay, so CAN, Controller Area Network Bus. What is it, right? And where's the security implication behind it? This is a protocol that is designed so that way you don't have a lot of cables connecting or wires hanging out everywhere, okay, in the vehicle. Because in wire management, number one, that reduce costs. Second, right, it is a better design for the automobile. You don't want things to be just hanging around, and production can be difficult. So what that does is it allows this, think of it like a channel or a location where things can be communicated with multiple signal, right? And it's like a shared bus. So think of like your computer system. When you plug a device onto a motherboard, that's a bus, one bus, right? But the way that they design this in cars is that one connection can be shared by many devices. So you not just one-to-one, but multiple-to-one. Because remember, we want to reduce less connection, physical connection. So we allow that logically to receive multiple signal on, basically it's a shared bus. So to share this, you basically assign priority, first come, first serve, or based on the need of that device. So for example, when you turn on your car, right, your computer activates, but your starter also works, right? And then other things would work, like your crank and, all of these things that makes the motor runs, okay? So that means that there is priority in components of the vehicle that would take place. And it also have a CPU, so that CPU, the processing unit, is going to be the controller for ultimately the car. So that means that you can have multiple devices or nodes send information at the same time to the bus. And then the highest priority of the device is gonna get served first, okay? So CAN is really designed for that. Now, the flaw of this is it lacks security. So that means that there can be tampering, because remember that instructions is sent to the bus multiple at once, right? And whichever that has priority is going to be served. So man in the middle can occur because some form of instructions can be submitted to that bus and it can be executed. For example, right? Apply brakes while the car is moving, even though you don't tap the brake pedal, right? So through communication, they can intervene and be able to perform a man-in-the-middle attack. That means it just interject with the code, submit that to the bus and be able to execute your car attack. Another area for, I'm going to move this down so you can see both, sorry. And yeah, it's kind of long, but that's okay. Another security area that we need to look at and the technology for the automobile industry is the Modbus. So Modbus is a messaging protocol. I think this one uses TCP. And it uses in the integrated system for serial communication over cable type like Ethernet. You can have Modbus deployed in SCADA networks, and that allows us to monitor the systems remotely using terminals. Oh, did I go too far? So man-in-the-middle attack can be performed on Modbus. Because there is a lack of protection in message integrity. So this one focuses on message protocol, and it sends message for objects. So it touches on that on the notes, and you can read a little bit more about it. So here it gives you a little bit of a picture or a diagram of how the components on the car would work, right? There's some supervisions, and then you have to share CAN bus for like air conditioning, the panel, which is where you touch to turn things on or off, like your air conditioning, and then your battery, your engine control, and then the transmission. All of these components can be on the shared CAN bus. So even on the braking system, right, to stop your vehicle, like your ABS. So understanding how the communication works on vehicle, this is what you see with smart or regular vehicle, right? How it's designed, this is when you would see car attacks happening, or man-in-the-middle attacks that occurred, right? Okay, so there's some provided link if you want to read a little bit more about what that does. And then DPN3 or DNP3, which is your distributed network protocol. This is the protocol for integrated circuits for power distribution and water treatment company. And this is for another type of protocol for message relay between the supervisory and the management system through, or to, I should say to the PLCs. So it's used to transfer and maintain synchronization of tags between from the terminal server and SCADA system. And you see this being used in electric power system or your EPS communication. So for utility company, you often see DNP3 integrated. Like power plants and other area. And you can find this information. I clipped it mostly from the notes. So if you want to refer to that, you can. So the purpose of it is just to relay the message between the systems. That's its job, right? So one of the last part on the notes for the DNP3, it does support encrypted communications using TLS and PKI. So you have security in communication, using public key infrastructure. So it is a little bit better than what you've seen from the other two technology for automobile or the protocol. And then you have Zigbee. So Zigbee is a wireless protocol for home automation. It's implemented in a lot of different products that you see that provides for home, including Amazon or Samsung. So when you're using a central hub device to control thermostat, lighting, camera system, or even appliances, you then use Zigbee technology. So, example for Zigbee controller, smart camera system, like if you have like a centralized unit where you can see all your cameras, and it's wireless, right? I'm just saying smart wireless cameras. Or when you're looking at Google Nest, or if you're using like a smart lighting system, and that could be for decorative purposes or just home usage. So in the smart home environment, when you have a centralized controller that is wirelessly connecting to the other devices to control, right, that uses Zigbee. Or when we tell Alexa to control other things, right, through our wireless network. So the transfer rate for this is at 250 kilobit per second, and it uses 2.4 gigahertz frequency. So 2G, right, over 10 to 100 meters. So the distance is not bad. And it's really designed for home automation or home wireless technology. So what you have is you have distance range that would fit the proximity for the home. Okay. Any question? And then lastly, I think this is 17. Oh, we still have a few more. For the next question, it says describe the functionality of Common Industrial Protocol, which is your CIP, and the type of CIP networks. And you can pull this also from the notes if you don't want to type it out. So CIP carries message objects from sensors, switches, actuators, those are automated system or equipment in control plants. So when we look at CIP, that's just a protocol for communications between the sensors, the actuators for the network, right? And you can have Ethernet base, that will be Ethernet IP, that uses IEEE 802.3. That's a TCP IP suite. That's like your regular network, your common Ethernet based network. And then we have CompoNet, which is for controllers and industrial endpoints for those systems specifically, because the connection is a little bit different than what you see in the regular Ethernet network. And then you have ControlNet. That's for safety control, right? So this is going to be time critically for safety control. And so if you have systems that require that, you would have ControlNet. So CIP information, you can find it on page 14. And it talks about how it uses UDP and TCP. And the components, you would see that here. So your fourth component is going to be DeviceNet. I don't know, did I include that or it fell into the next page? Yeah, DeviceNet. And that is used with CAN. So it uses DC power over the connection, and you can have up to 24 volts for the supporting devices. Most of your smaller electronics uses approximately 10 and less, 5 to 10 volts. Or even less than that, 1 point something, sometimes 3, depending on how small it is and its functionality. So what you see is that for connections or for devices that uses 24 volts, that's going to be a little bit higher in the requirements that we see with that small electronics. And then for 18, it asks you to describe DDS or data distribution service. This is the middleware. So middleware lives between your OSs and your hardware. And it's used to publish message to subscriber. So ultimately, it is a way to simplify development for distributed systems. So that way, the functionality of the applications, even, for the development, just less complex. That's what it's saying when it sends information between the application and the system. So between software and the actual hardware, right? Because it's a middleware. So middleware is like a way that we can transfer between the software and the hardware level, between your OS and the actual hardware. So DDS does that, data distribution service. And that will be 18 questions for the assignment. We can save this and submit it to Canvas. So next week, Thursday will be Halloween. I will not have class attendance requirement. If you want to spend time with family for Halloween, you're welcome to do that. I will open a quiz on Canvas. All I require you to do next week is do the quiz, and if you want to do the extra credit quiz review game, you can. That's all you're gonna do, right? And then when we come back the following week, which is the week before Thanksgiving, I believe, right? Um, we're gonna talk a little bit about our project, and then we'll continue with our assignments and lab. Um, as you can see, so I'll think about something that we can pull this information that we are learning today. Possibly maybe we can take a look at some way that we can assess IoT devices or something that would be more relevant for the field. And then also the next chapter on the exercises. So but we need to address the project so that way you can plan out on how you want to put together your security plan for the request for proposal. So basically your project is going to consist of an arbitrary company that would have a certain requirements for their system to be secure. And then you would put together your security solution for that particular company. So that's called request for proposal. So you're gonna have a proposal where there's certain needs that the company wants. And then you are going to look at like the network, the application aspect, all the security layers, and then even the policy area, and then to be able to integrate that. And you can work with someone else in the class on the project, right? So I would prefer that you do a small group so you can collaborate and share ideas and look at how you can approach. And during the project phase, you're welcome to ask me questions so I can serve as your advisor for the project. But at the end of the project, you will put together like some form of solutions in documentation so that way, and you can use that for your portfolio to show companies that you're applying to that you're able to deliver security solutions, a full security solutions, you know, and then I will assess based on what you provide or your team provide. Unfortunately, I don't have a recent example of the project. I will have to go and look back into some of my old stuff to see if I still have some student project from the past. But their project is probably not as relevant because if it's in the past, they might use older technology and things that might not be even effective as security solutions. But I will have criteria where you will meet for points. So it would tell you what you need to deliver. And then you will be assessed based on that. So as long as you go through that checklist, and we will go through that together when we come back after Halloween. So that way you have a good amount of time. Because this is what week 10. So you will have like approximately a little bit more than a month to kind of work on it. So I would say chip at it a little bit every week. So by the end, you will have it done. And we do have a final exam, and I intended to capture all the concept along with adding a little bit of, you know, practice exam questions into your quiz and your final exam. So that way you have a little bit of the practice exam. This certification is called CASP. It is a highly demanded certification, and I do have voucher for the certifications. So after this class, if you want to pursue this certification, as you can see, it has a lot of high level concept, but it entails everything that you also learn in the other security classes and also the networking classes and so on. So if you want to pursue it, we do have voucher to accommodate. Okay. I didn't buy that many. I bought like 25, so it should last at least for the year with CompTIA. Okay, let's stop recording. We can take a short break if you need a break.